So yesterday we have discussed on system on chip design, right? So a lot of you have some doubts regarding what is meant by a processor, what is meant by pipeline and non pipeline, how the instructions are executing actually, what is the difference between assembly language programming and this VLSI hardware design, what is the major difference? You have a lot of doubts, I think. So I told you we'll discuss today's session, right? So let me start with this again from processor onwards. Okay. So as you already know, it's a system on chip design. Nowadays, whatever the most of the chips we are using in the mobile phones and laptops, so same type of architecture will be there. But it will be in terms of billions of transistors integrated on a different functional blocks. That's what we call integrated circuit, right? So if you see here, there is a CPU subsystem on left top. It's a processor related. That means every type of processor, whether it's a central processing unit or graphic processor, multi-signal processor, digital signal processors, analog processor, image processor, audio processor, everything there will be subsystems, different types of subsystems for the processors. So inside that there will be n number of cores. Cores are nothing but the processor. Okay, core is nothing but it perform two task. Example, if we see, suppose there is a one processor called MIPS. What is meant by MIPS? MIPS is nothing but millions instruction per second. That means within a second it is running millions of instruction. By running the millions of instructions, it is performing multiple tasks. Right? Suppose I'm talking here. Whatever I am talking, that instruction is sending from my brain. Okay, whatever I am talking, that is a task. If I write something, that is a task. If I think, if I am doing some more task, that is nothing but task. But getting the information while I am doing the task is the output. But where I am getting the information, where I am getting the instruction, that instruction is nothing but getting from the brain. In the same way, processor get the instructions. We write the instructions using assembly language programming. That instructions it do in terms of task, whatever it doing something like you have connected a mobile phone to your laptop and you are sending a file to your laptop. But internal what hardware is doing, we cannot see that. Actually, processor allocate some task, some instructions to do that task, to transfer the files. That is what the task. Suppose here I have opened the Google Chrome, or I have opened some software will be connected to the hardware. Actually, as I told yesterday, there will be a operating system, the interface between hardware and the software. So on top level, whatever the software we are using, that's what the task is done from the processor. That's what the instruction is generated by the processor. Did you all understood, everyone? So if there are more number of cores in a processor means it do lot of task, it do multitasking, parallelism is possible. Okay, in 2G mobile phones, if you take example, it also have a processor. In 5G mobile phone also have a processor. But what is the main difference? Only the difference is some of the features and the core. In 2G mobile phone, maybe they have only one or two cores, but now in present mobile phones, we are having hundreds of cores, hundreds of central processing units, thousands of graphic cores in the laptops, in the mobile phones. That is how we are able to do the multiple tasks within a seconds. Even we are able to do some task with some artificial intelligence, some AI applications, which are very fast applications, not like just gaming or just like a WhatsApp, Instagram, right? So that is what the powerful, that is what the power of internal processor it is doing. Like that, there will be lot of peripherals. Okay, there will be lot of peripherals like memories will be there, different types of memories, different types of um, Bluetooth connections, Wi-Fi connection, camera module, and some video related, some audio related, battery related. So everything is packed onto some chip. Okay, that's what we call as a system on chip. Did you understood, everyone?
Yes, ma'am. Yes, ma'am.
Okay. Another thing, example. Yesterday, I have shown you the assembly language programming, how it looked like. You already learned assembly language programming in your third year BTech. You know how to write the instructions. I think you have did some examples for Fibonacci series, even or value detectors or parity detectors by using add instruction, subtractor, multiplication, logical, some branch type instructions, jump type instructions. You already written, right? If you remember, I think. So those instructions are nothing but they are all going to store in some memory. Okay, they are all storing in a memory. Example, MIPS processor if I consider, or RISC processor if I consider. Okay, to execute an instruction, it have several stages. Okay, to execute an instruction, it have several stages. Suppose here there is a register. Suppose you are writing a add R1 comma R2. R2 is some general purpose register, R1 is some general purpose register. So there is some register bank here. Register bank in the sense where it have n number of registers inside it. Okay. Suppose here there is some register bank or some register which stores some instructions and all. Okay. To execute these instructions, whatever we are writing the instructions, to execute that, it will follow 5 stages. Okay. First of all, uh, first thing is a instruction fetch stage. Next one is a instruction decode stage, instruction decode or register fetch we can call. Here next one is a execute stage, and next one will be the memory state, and next one will be the memory write back stage. That means after doing the memory, we are writing back that register into the register file. Here write back stage. What is the importance of write back stage? Again, why it is writing into the register file? Can anyone tell? Hmm?
Updated value.
Okay.
We'll add the initially we'll store the value in a cache memory, then we will write it back to the main permanent memory.
Okay, so that is nothing but, as some of you told, it's an updated value. Suppose initially I am doing a addition operation for R1 and R2, R3 and R2. That addition of these two values will be stored into the R1. So here now whatever the R1 got the data, again the data should be transferred to here. It should update the value here. Okay, like that here R2 is there. Again for subtraction we are doing the subtraction of R2 and 10. That value is updating to the R3. So that's why here again it should go to the write back stage and store the data into the register file. And in multiplication, we are doing the multiplication of R1 data and 18 data. That means whatever here we did the addition operation for R1, whatever the updated value is there, for that updated value, we are doing the multiplication with the 18, and that we are storing that value into the A. Okay, that's why the register write back stage is much important. Okay, so to execute this instruction, suppose there is a add R1, R2, R3. That means first of all we need to fetch this R1, R2, R3 values here. Whatever the register values or immediate address or we have index type of instruction set. Okay, there are different types of addressing modes and instruction set, right? If you remember, so all the data we are fetching to the instruction fetch stage. Okay, so here after fetching the instruction from the memory, usually from cache, in the cache only we will have all these instructions. Okay, and these data will be decoded, fetch to decode stage. These instructions will be decoded, it controls the signals that it is generated. Okay, and also register operands will be written here. Okay, it decode, that means add, for add it has some binary data, that binary data will be decoded here, and register have some binary data, that data will be decoded here. Okay, after decoding the data it will go to the execute stage, because whatever we are writing here, ALU, arithmetic and logical operations, right? Mostly jump type or branch type, everything will be the arithmetic and logical operations. So here there will be some ALU to the in the execution stage. It performs the instruction execution here, whatever uh, we have written operation here, according to that it will do the operation. Okay, it calculate the address for the memory access, and then next, memory. After executing, it will be sent to the memory accessor. So what will be happen here? If it is a load or store instructions, the data is read or written to the memory. That's what the memory access. And whatever the updated values are there here, here it will be doing the write back stage R1. Okay, so this is what exactly happening on top level hardware. As a VLSI engineer, we need to design RTL design the instruction fetch. We need to design the decode stage using RTL, that means using Verilog and digital circuit, and also execute stage, memory stage, write back stage. Whatever these instruction sets are there, these are the assembly language programming which can be done by the embedded system engineer. Not only embedded system, even there are subdomains related to the microprocessor. Okay, even in VLSI also the team is different, who written the instruction set architecture. Okay, uh, so this is what exactly happens on the top level. Did you understood everyone here? This everything will comes in a hardware. For instruction fetch there will be a hardware, decode there will be a hardware, like that. This is for simple risk architecture, risk 5 we can call. That means 5 number of stages will be there to execute a single instruction. Like that, if you go with the CISC processor, most of the laptops use the CISC processor architecture only, because it's a complex instruction set architecture, which is like a x86 AMD Ryzen processors. Mostly
So
it
what is
takes
the
lot of
difference between
stages,
these
like
risks?
nearly 12 to 20 stages will be there. Here we have executed only 5 stages, right? In CISC processor it have more stages, nearly 12 to 20 instructions stages will be there to execute one instruction. Like that superscalar, yesterday I have shown you superscalar out of order processor architecture. So it have lot of stages. Yeah, please tell, what's your doubt? Hello.
What is risk and risk?
CISC and RISC. RISC in the sense it's a reduced instruction set architecture. It is not much complex. As I shown you here, just 5 stages required to execute one instruction. But CISC is a complex instruction set architecture, because if you see simple example, our laptop we use a CISC architecture, because in laptop we need to install a lot of softwares, different type of tools or softwares. But in mobile phone we cannot install those tools or softwares, right? Mobile phone applications are different, laptop applications are different. So in mobile phone we are using the risk architecture, which is reduced instruction set, less complexity. But for laptops, Cisco and also super complex superscalar architectures, like out of order architectures. Nowadays it is getting VVIT, so very large amount of instructions will be there. So like that there are a lot of series.
Who will write coding for this risk?
Who will write? Mostly risk architectures will be written from the ARM. ARM is mostly specialized in the RISC architectures. So there are actually for RISC we have standard ISA instruction set architecture, and it is also open source. RISC is a open source, but CISC is not a open source. Even you can search in the Google, you will get the RISC architectures and all. Mostly ARM. ARM is the main company who supplies these RISC. And also, if you are facing some
But ARM is
interview
not
with,
open source, right?
huh? Sorry,
ARM is not open source.
ARM is not. Your voice
So
is
ARM is
breaking.
source. ARM is not open source.
I'm not telling ARM is a open source. RISC is a open source. Open source in the sense
Yeah,
not
but
totally. We don't get
ARM
in
comes under
lot.
RISC only, right?
Yes, yes. ARM basically, suppose x86 is there, x86 Pentium processor. These all are Intel based. That's like RISC. The RISC is a ARM based. Ryzen is a AMD based. Like that. Snapdragon is a Qualcomm based.
Open source means
Open source in the sense in Google, you will get the architectures and all. That's what open source. Anyone can use. Anyone can get the data regarding the RISC processor, but no one will get the data regarding CISC processor. These all are internal company things. Like they have a lot of disclaimer like that, right? So we cannot get those things.
So every RISC architecture comes under open source.
Actually, it have a lot of versions. RISC architecture is not just this year or last 5 years. RISC architecture is there from last 20, 30 years. So there will be a lot of advancements coming in that. But whatever
But
the
most of
advancements
them,
are,
all of them are open source only.
no. We will get only basic architecture in the open source. We never get what exactly happening in the industry, what exactly the features they are putting in the architecture. We never get. Even these SOC architectures, these blocks will be common for every SOC. Whatever the company you prefer, every SOC, these blocks will be common. But there will be lakhs of blocks which are their own. iPhone have their own architecture, AMD have their own architecture, Intel have their own architecture, even the protocols they have their own. The debugging things also, debugging also, there will be special domains will be there. They have their own, but basic idea will give in the open source. That's what.
Yeah, my question is like, all the RISC architecture are open source or not?
That's what I am telling. Not all RISC architectures. The basic idea we will get the open source. Internally, there will be lot of additional features. Those we don't get in open source.
ma'am. Actually, RISC is architecture name, na. So RISC type processor is a processor name.
Mm. Yes, in a processor we use these architectures. That's what.
So that's why its name is RISC type.
Yes.
So ARM, MIPS both come under RISC only.
No. MIPS is different. MIPS is a old style. Like MIPS is
CISC.
what?
MIPS CISC.
MIPS is like a millions instruction per second, but RISC is a more advanced than MIPS. RISC is a billion instructions per second, and also it have pipeline stages.
No, like I mean, can I segregate it under CISC?
No. MIPS is not related to RISC or CISC. Both are different.
Okay, they have their own instructions.
When we are writing code like with UVM based RISC processor, we have to check with verification when we have to use test benches like how we have to do testing.
Okay, this thing also I want to tell you. Another thing, most of you will get a doubt. I will answer this question before explaining this pipeline. Okay, just a second. Let me complete this pipeline. So how many of you know about the pipeline? What is mean by pipeline?
Pipeline means executing of stages parallelly, somewhat parallel.
Huh. So before I have drawn, there are 5 stages. One is the instruction fetch stage, another one is the decode stage, execute stage, memory access stage, and write back stage. Okay. So in RISC processor, to complete one instruction, it nearly takes these 5 stages. Okay. So first stage is 1 second example I am telling. Second stage is the second. Third stage is third second. Fourth stage is fourth second. Fifth stage is fifth second. Suppose to execute one instruction, it is taking nearly 5 clock cycles and 5 seconds example. So to complete second instruction, 10 seconds. To complete third instruction, 15 seconds. To complete fourth instruction, 20 seconds. Like that, every instruction is considered, it's occupying 5 seconds. Okay. So without doing that, pipeline is nothing but it's a non-pipeline. Okay. Pipeline is nothing but parallelism, where we can do multiple tasks. Suppose the first instruction is in fetch stage here. Whenever first instruction is going to next stage, decode stage, now second instruction will immediately start here, second instruction. Now whenever first instruction is moving to the execution stage here, now second instruction will come here and third instruction will come here in the fetch cycle. Whenever the first instruction is moving from execute to memory access, here first instruction, second instruction will come to executor, third instruction will come to decode stage, fourth instruction will come to fetch stage, and finally whenever the first instruction is moving to the last stage, write back stage, the second instruction will come to memory access stage, third instruction will come to execute stage, fourth instruction will come to decode stage, fifth instruction will come to fetch stage. So if you observe before, in non-pipeline, to complete one instruction, it is taking nearly 5 seconds, 5 cycles, right? But in now, within 5 cycles, first instruction got executed and second instruction is almost getting it, and third instruction is almost at a execute stage, fourth instruction is also started, fifth instruction also started. So this is what the pipeline. Now in before, in non-pipeline, to complete four instructions, it took 20 cycles, 20 seconds example. Okay. But now in 20 seconds, we can able to pipeline till 10 instructions, 15 instructions in 20 seconds. Okay. So that is what the pipeline, so that the execution process will be more, the speed will be high. Okay. Did you understood everyone?
So
Yes,
these
ma'am.
stages
Yeah.
are hardware block in the processor.
Yes, it's hardware block in the processor. It have a lot of complex blocks actually. Fetch stage have the complex hardware again. It have lot of stages, arithmetic and logical units. Multiplexers will be there. Some registers will be there, and even for decode stage here, there are a lot of internal hardware design for each stage. And it totally depends on your instruction set architecture, like what type of instruction type you are using, branch type or jump type, or um, like arithmetic and logical type, like that.
And since they are stages, how are these stages connected with each other?
Yeah, of course, there will be a connection. There will be some signals which are connecting with these stages. These output should get to here. There will be some stages internally. This is what
Yeah.
exactly we are doing in the project. In risk, like, or in our curriculum, there is a RISC-V processor project, right? So we are going to design the fetch stage individually, decode stage individually, execute, memory access, write back, all hardware individually, and then top level connections, and then system Verilog verification.
Ma'am,
Yeah.
these stages are the only present in the RISC-V processor.
5 stages in a RISC processor. Like that, CISC have different MIPS also have the stages, but not 5. It have 3 or 4, like that. and pipeline versus non-pipeline. Like that, it will differentiate the concepts.
Okay.
So both the SISC and RISC are pipeline.
Yeah. Without pipeline, SISC never works. Even RISC also. Just it increases the speed of the operation.
Ma'am,
And
I have a
also
doubt.
here we need to understand the clock, how to calculate the clock frequency here, the time, how much pipelining time. There are some internal concepts we need to understand. Yeah, please tell.
Ma'am, instead of doing pipelining, we can also do multi-cycle also, right?
Multi-cycle, how we can do?
Like we can pass instructions through multiple cycles instead of doing pipelining. I mean, it is a simple version of pipelining instead of in case if we don't understand what pipelining and how it works.
Multiple instructions in a cycle. Okay. Okay, multiple instructions you want to send at a time, huh?
Like it goes through one complete cycle. It takes one complete cycle to do it, ma'am.
Okay, you are telling there are 10 instructions, suppose all 10 instructions you want to send at fetch side at a time, right?
What I meant is like in one instruction,
Mm.
it is executed in multiple clock cycles. Like each step will do one small part of the work, like fetching, decoding, executing, memory access, and write back. So like in cycle 1, it'll do instruction fetch. Cycle 2 will do instruction decode, where in case if we take add as the example, which we have taken add R3, R2, R1. So like get the instruction from memory and put it back into the instruction register. All of this will go in completes in multiple short cycles. Like you have a faster clock instead of each step is shorter. So
Yeah,
like
here also we are doing same clock cycles. What it means, small shorter clock cycle, it doesn't mean like that. Whatever it's a clock, that's it. We need to follow the stages because one output is dependent on another stage. Even here, whatever the write back here R1, suppose we are getting the output. Next instruction is dependent on this output. That's why we need to wait until we get the R1. Did you got my point?
yes, ma'am.
Everything is dependent. That's why here R1 is getting to here means these many 5 stages we no need to wait. If it is here, if it is getting R1, here next stage also will immediately the value will be reflected. That's what exactly pipeline. We no need to go for first stage for R1. We no need to start from here first stage. Did you got the point?
Yes, ma'am.
Okay. So next, next question is, some of you asked what language we need to use to verify the processor actually, right? So if you see in a system on chip design, this is what exactly SOC architecture, right? Girls, is there any doubts?
No, ma'am, it's clear.
Okay. See here, some of you asked what type of language need to use to verify a processor. Actually, if you see, it's a system on chip design. In this system on chip design, except processor, except a processor, whether it's a central processing unit or a digital signal processor or image processor, whatever, except the processor, remaining entire circuit will be the hardware only. RTL design, where we write the Verilog program and generate the circuit netlist for that. Okay, but processor, nothing but core. Core is nothing but it's an assembly language programming. It's an instruction set architecture. Okay, so that's why whenever you connect in industry if we speak, whenever you connect the core to hardware, we never verify that core test cases using system Verilog or UVM. System Verilog and UVM is used only to verify the hardware description language, that is a Verilog HDL or even VHDL. But here for processors, especially we are designing using the instructions, assembly language programming. That assembly language programming is never verified using SV or UVM. It is verified using
But
C or C++.
processor is also a hardware, right? We can use system Verilog.
Yeah. See, processor top level we connect the hardware. Fetch, decode, execute. To do the fetching, we need the hardware. To do the decoding, we need the hardware. To do the execution, we need the hardware. Entire instruction is executed using the hardware. Simple example. If you want to run some software,
Yeah,
on
since it is
top
hardware,
level,
we can use system Verilog also, right?
wait, let me complete. Suppose if we are using some software on the laptop, we cannot directly use that software without the hardware, right? In the same way, to execute the instruction, to execute the millions of instruction, in the down level we need the hardware. In the top level, all the instructions will be executed. Instruction execution test cases will be different. These fetcher, decode, these test cases are different. Anyway, hardware, I only told that fetch there will be a hardware, decode stage will be a hardware. That hardware we can verify using system Verilog or UVM. But whatever the instruction set architecture we are writing, that cannot be verified using system Verilog or UVM. We can verify only C or C++ test cases. Okay, sometimes even this nowadays, not even nowadays, in from past a few years, this also verified using C language. That C language, this also verified using SVUVM, that will be converted into the C++ also. There is some concepts like a direct interface, direct programming interface, DPI. So by using this concept, we can convert the system Verilog test cases to the system C language to system Verilog. That's the another thing. But whenever we are using the assembly language programming instructions in the core, it cannot be verified using SV or UVM. That's why if you see any job description, if you are applying for the senior role positions in mostly in ARM, if you see computer verification, CPU verification role will be there in ARM. Even in Intel, AMD also will be there. CPU verification means definitely they will ask RISC processor and C++ language. Definitely these will be there for C++. If you go with ARM, suppose. Before I think some website is changed now, updated, so it's not getting. You can even log in here. You can even log in to find the jobs.
Ma'am,
Yeah, tell.
millions of execution, ma'am, risk. How to transfer, ma'am, without using pipeline?
Wait, see here, required skills for experience. Verilog, system Verilog, RTL design, and test plan. Creating test plan, test cases is must for verification engineers. If you don't get proper creating the test plan and test cases, then it's not very easy to crack the interview. Okay, verification means it's a creating the tests, creating the test cases, test plan to do the functional verification. So that is most important. And also if you see UVM is very important for verification, and C++, these all must. And microprocessor designs, the CPU execution, how the interrupt handling, how the memory protection. These are some of the concepts. Constrained random simulation in system Verilog, and coverage is most important. Like if you have any some artificial intelligence. So this is nowadays, but before also same. You must have the C++ if you are applying for the CPU verification, especially. CPU verification means nothing but the processor core team. Okay. See, CPU verification, ASM, assembly language programming, C++, VHDL or Verilog HDL. Both are linked only for CPU, not for remaining RTL design. It's not required. Okay. Any other doubts remaining?
Yeah, ma'am, it's clear.
Ma'am,
Tell.
you're saying SOC, right? On SOC, first there is processor and some other blocks are there, right? So when we check SOC level test cases, I don't know, maybe first of all processor test cases are start, right?
Processor test cases?
Yeah, you're saying all different blocks are there, like processor, some other memory blocks, some other things. Yeah, these each block has separate individual test cases, right?
Yeah, separate. There will be lakhs of test cases for one SOC. In that lakhs
Yeah.
of test cases, there will be lot of thousands of teams will be there. See, if we are handling one project, suppose there is a one AMD Ryzen processor related project, means that project it will be not from India, it will be some other countries. So there will be lot of engineers, lot of teams involved in that, in a PD flow and also in front end. Now here in there will be different projects for Hyderabad team and Bangalore team, suppose in AMD. So in Hyderabad team also, but for that one project there will be nearly thousands of engineers involvement. Okay, and the teams will be divided, core team and memory team, not like that. Internally there will be lot of specific names which I should not tell out. Okay, there will be lot of teams even for testing, validation, even in pre-silicon, post-silicon, DFT, DFD. So there will be lot of team. In that, if you are a fresher, you will get the work to write a simple test case, not even writing a simple test case. Maybe you will get the debugging work. If you are having 3 years or 4 years of experience, real time, you will get it writing a test case, that too 1 or 2 test cases initially. In lakhs of test cases, only 1 or 2 test cases you will get the task to do. Suppose if it is a SOC level or even IP level. Okay, so you no need to bother about whole SOC and all the modules and all. Okay, at this level you just need to concentrate on how the exact processors are working. Just take a project like a MIPS processor initially. You can try to implement the stages of MIPS processor, and after completing you can go with the RISC processor. Like that in memory related, just pick a RAM memory initially, next a ROM memory, FIFO memory, LIFO memory, and then SDRAM, DDR. After this you can go with the DMA controller. So this is what the you need to learn. This is how the process you need to learn. Okay, memory related. Next.
Ma'am,
Yeah.
here I'm asking about your, for example, we are taking a motherboard. If we are, I'm taking motherboard as an example. Here it has some clock, some reset blocks, and some other R blocks. When we are coming for the SOC testing, it is like already unit testing is finished when we coming for the SOC level testing. It is all about the integration and how the AXI interconnects and AXI protocols are connected each other blocks and how the signals are transmitting from each other blocks, right? So here we wrote for each each block has different test cases. I'm asking about is any sequence that after this block only this block should be this
Yeah,
block
of course.
should be execution. Is that
Yes.
any
Yes,
mandatory?
yes.
Is that like that?
There will be a flow. We need to follow the flow. The execution flow will be there. And also you are telling after everything is ready, like you are talking like hardware SOC, right? That means
Yes, yes.
post one. Hardware SOC. Yeah, I understood your point. Hardware SOC means suppose example, I have a concept on this regarding a protocol. Let me show you. So this is what you are asking, I think so. Suppose the right side there is a chip. It's a SOC hardware already done the manufacturing process everything. Now you want to verify these internal test cases, huh?
Yes, ma'am.
Okay, so here we have a special team called DFD, designed for debug. The team is nothing but where it do the verification in a post silicon. Anytime we have the two domains, a pre silicon and also post silicon. Okay, post silicon means after the chip is ready, after manufacturing is ready, there
tape
also we will find lot of debugging issues. So how we are doing the debugging here means this SOC we will connect with the debug unit. Debug unit is a special hardware. It's an extra hardware. We will connect with the different IP blocks here, different functional blocks here. By connecting that to the different functional blocks, there is internally lot of things happen, like for the debug unit we will take the information to the debug units. Okay, suppose there is a GFX graphic processor, there is a DFX data fabric, and NBIO North Bridge IO, SBIO South Bridge IO, and PCIe related, AXI related. So from every team, every block, we will gather the information of tests, all the test cases information, and there again we do the functional verification, whether every test is verifying properly or not, whether it is getting the coverage 100% or not. Everything we will check, even the manufacturing process is completed. Okay, and another thing, if you see here, there is a JTAG adapter in the middle. That means this is a FPGA. This is a FPGA which is used to take the information of SOC by using the JTAG connector. JTAG is a connector like USB, and
Yes.
it is getting the data from the JTAG and sending to the computer. Computer is nothing but it has the tools. Suppose in AMD we use the Verdi tool for debugging the test cases and all, to check the everything, like whether it's a front end or back end, mostly for simulation. We use the Verdi tool, and there we will have all the test cases, core related test cases, GFX related test cases, PCI related, DFX related. Everything will be given here, even in a DFD team, post silicon, and we do the verification 100%.
That
Did
means,
you got the point?
Yeah, that means you're saying from the PC your test cases are dumped onto the chip using the JTAG, right?
Yes. Test cases will be not dumping. We
Yeah,
will
that
have the extra hardware which is a debug units. There will be some debug streaming, DBGSC blocks will be there. Debug bus. Debug bus means whatever these. Suppose I will draw it. This is what the hardware SOC. Here I have a GFX blocks. GFX, DFX, NBIO, SBIO, PCIe, AXI. These are some blocks I want to verify. There will be bus connection, debug bus connection. Through this, the debug bus units, we will connect these all in a cross trigger network. If you see DFT teamer, in DFT teamer, what it means testing, it's a testing. That means by inserting the scan chains, by using the BIST mechanisms or ATPG mechanisms, so we get the data and we do the testing. They will connect in a scan chain fashion or daisy chain fashion. In the same way, in the post silicon, we connect all these debug bus in a daisy chain fashion, and we will collect all this information into the debug units, which is a separate hardware we need to insert. Okay, so here in this debug units, we will get all test cases where we are finding the error. Suppose here some test cases are failing due to some power on reset is not working, or the handshake mechanism is not working, like a right read operations. So all these test cases we can observe here. This information we are sending to the computer, which is a budgie tool, by using the wombat in the middle. That's what FPGA using the JTAG connectors. So here we will get all the information in the software, and what are the test cases failed and what are the test cases are running. Based on that, we do the debug and we do the fixes. Okay.
Yeah.
Every project, there will be some timeline, 1 year or 1.5 years, every process. So based on that timeline, there will be milestones. Every 2 months, there will be milestones. So milestone in the sense, suppose project is 100%, means every milestone they need to reach 20%, 30% coverage, they need to reach 30%. Like that, depending on the team, there will be some milestones. As a verification engineer, we have coverage, we need to reach the coverage 100%. Functional verification, all test cases should be passed. That's what our verification engineer must do. Okay.
Okay, ma'am.
Ma'am, I have a doubt.
Yeah, tell.
Ma'am, by this bus flow, sometimes there is a collision may occurs, no ma'am. So how to clear that?
See, collision in the sense, what do you mean? Like a wire connections or data?
No, ma'am. Sometimes the data may be corrupted, or else like it going to be lost. No, ma'am.
Yes,
In
yes.
that sense. So how to overcome that?
So yeah, that is all depend on the test cases only. The data is corrupted means, again we need to recheck the test cases according to the functionality, and we need to verify where the data is mismatched, and we need to do the debug. We need to fix the errors, why exactly it is data is corrupting. There will be various scenarios. Data is corrupted means it totally not one straight answer. There will be various scenarios why the data is corrupted. So based on that, we need to deal.
Yeah, okay, ma'am.
Okay. Any other doubts remaining?
Ma'am, can you
Hello,
explain
ma'am.
about
I doubt.
SOC protocols?
Yeah, that's what
Hello?
our next concept.
Okay, ma'am.
Ma'am, adding to the previous question, like in the bus transmission only, what if some part of data is coming at one rate of speed and the other part is coming little late? How are they going to tackle that, ma'am?
Okay. So we will discuss the protocol first. For that question you will get the answer from here in protocols. If you don't get the answer, I will explain again. Okay. Next, most importantly, what is mean by a protocol? Can anyone answer?
It is a set of rules.
It's
Set
like a
of-
bridge between.
It is set
Set
of
of
rules.
guidelines, ma'am, for
It is like a bridge between two persons, like communication purpose.
Okay. Any other answers?
To basically communicate between two different components. So we can use it to communicate with the SOC chip to the external part. One of the uses is
Set of instruction how our data needs to be handled.
Okay. Regular students, anyone there? DV students. Okay, fine. See here. First of all, it's a system on chip design. There are various functional blocks in a SOC. Okay, to make the communication between one block to another block, we need to use the wire connections, even wireless connections. To transfer the data, we need to follow set of rules while transferring the data. Correct. That is what exactly mean protocol. Protocol is nothing but we are transferring the data using set of rules. We need to follow the set of rules. Okay. Suppose example, here there is a processor. Okay. Processor means it's a very high speed. It works in terms of gigahertz. The billions of instructions will be executed per second. The billions of instructions. Okay. All these instructions will be sent to only one block? No, right? All these instructions will be sent to the various signals. Internally there will be lakhs of signals, lakhs of functional blocks. It will be sent to all, right? Suppose we have a brain, human brain. Whatever the brain sending some signal, that signal will not come only to my mouth if I speaking. It doesn't come only to my hand if I'm writing. It will that instruction will go entire body, to all nervous system, to all bones, everything, from top to bottom, right? In the same way, the processor is generating some instructions, means that instructions will be connected, will be sent to entire system, every signal, every functional block, every digital circuit, every adder or even subtractor, even small buffer also it will send the data. Even top level software also will be connected to that processor, right? So that's why processor should be a very high speed. It generates billions of instructions. Okay, but example here processor is a very high speed because it generating billions of instructions. But here right side display is there. There is a display board. Okay, display no need to work with respect to entire instructions of the processor, right? It just work only for fewer instructions of the processor, because the processor will send only fewer instructions to the display. Remaining all instructions will be sent to the various blocks, right? So this is where actually the frequency mismatch will be happen. The processor will work at a very high speed, but the display will work at a very low speed. We need to make the synchronization between these two without any data loss. Without any data loss. And also, processor will accept only parallel data. All instructions, all tasks it do parallelly. But in the system, there are a lot of serial communication blocks out there which accept only serial data. That doesn't accept the parallel data. So that time what we need to do? We need to convert the parallel data to serial data to parallel. Okay. Another thing is, in processor, it accept both write and read operations at a time. Both write and read at a time. But in the same SOC system, there are a lot of blocks which cannot do write and read operations at the same time. They do only, they work at a duplex, half duplex, not full duplex. But whereas a processor works with a full duplex. Okay. And another thing, another classification, there are a lot of cases where we do inter-system communication and intra-system communication. Okay. What is meant by intra and inter? What is the difference?
Communication within the processor is inter and outside the processor is
Intra. So if you do the communication within this SOC, within this system on chip, that means with this processor to memory, with the processor to IO peripheral, with this processor to some other processor. If you do the communication within a chip, that's what we call inter-system communication. But most of the times we will connect your computer to your mobile phone, right? This is my computer. This is my computer. And this is my mobile phone. How we are transferring the data here? We can connect using the wire, or we can connect using Bluetooth. Bluetooth is a wireless communication channel. Wire is it's a wired communication channel. Okay. So suppose you are sending in your mobile phone, there will be a port which is a B type port or C type port. In your computer or laptop, there will be some port which is a USB port. Olden days we have UART port. Nowadays we are using USB port. Okay. So here also it should follow some certain rules to transfer the data. Coming to B type, it have some specific features. For USB protocol, it have some features. Okay. So whatever the data you are transferring, suppose you are transferring a file from your mobile phone to your laptop. Okay. How you are sending a file? You are connecting to USB. That document will be sent, but that data will be sent in terms of binary 10000110. Like that, the data will be sent to in the binary, which is using a protocol. Protocol is nothing but here it follows certain rules to transfer the data. Basically, transfer the data. So that physical format file will be sent to your laptop. That's what we observe. But internal transmission will be done in terms of these digital numbers. Okay, the same PDF file format we can observe in your laptop. This is one of the protocol we use, USB, very high speed protocol, serial communication protocol. Okay, understood? Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And if you observe here, there is a bus. These big interconnects are there, blue color, and here green color, and here there are small blue color interfaces. So what all these? These all are nothing but the protocols. These all are protocol, which is a parallel communication protocol. Which is a parallel communication protocol. Why? Because in this SOC, these bus connections are used to connect the subsystems. This is one subsystem, this is another subsystem, another third, fourth, like that. There are various subsystems. To connect these subsystems, we need to transfer the data in parallel only. Okay. So here, the processor will work at a very high speed, but remaining subsystems may not work at the same speed. Okay, so that's why we use a parallel bus protocol, high speed parallel bus protocol at processor side, and low speed parallel bus protocols at here remaining IO peripheral side. Okay, suppose high speed bus protocol, we have AXI protocol. Processor side, memory controller side, we use AXI protocol only. Remaining small peripherals like timers, watchdog timers, or display ports, some HDMI ports. That time we use APB protocol, which is a low speed, and also it doesn't have much features. Very less features will be there. So there are three types of bus protocols. One is a AXI protocol, AHB protocol, APB protocol. These three protocols you are going to learn in this particular course. So APB protocol is nothing but low speed, which is a parallel communication protocol to connect with the small devices. AXI is a very high speed to connect with the top level processor memories. Okay. And you may get the doubt. Some of you got the doubt also. If it is working at a high speed and someone is working at low speed, how the frequency communication will be happen this between? You got the doubt, right? So what the answer means? What is the answer means? We need to match both the frequencies. Okay. How can we match the both frequency here? Here we are using the bridge. AXI to APB bridge, AHB to APB bridge. Bridge is nothing but it will convert the high speed data to the low speed data. High speed data to the low speed data. It is also a separate bridge. Okay. Example I'm showing here. Suppose in system Verilog there is a block which is a generator, or you can think it as a transmitter, and there is a receiver, and there is a receiver. Now transmitter is sending lot of data, nearly 10 number of transactions in just 1 second. 10 number of transactions in 1 second, and it is sending to the receiver, which is a low frequency. It work at low frequency. Okay. The receiver may receive, or it complete its task for only 5 transactions within 1 second. Within 1 second. Okay. After this 1 second, the transmitter is sending another 10 transactions to the receiver. Again, receiver is stopping that ongoing function, ongoing operation, and again receiving the 10 transactions, and again it able to do only 5 transactions within a time, and remaining 5 transactions are lost. Before these 5 transactions are data loss, and next 5 transactions are data loss. Okay, so that is not effective communication. That is not the effective data transmission, right? So for this purpose, what we can do here, how can we make the frequency match here without any data loss?
Can we use synchronizers?
They are already synchronized.
We use bridges.
Someone told.
Pipelining.
Can we use buffers like?
What is mean by pipelining?
We use bridge.
We use registers and latches in between.
What is the difference between register and a latch? Can you tell?
Latch will not store any data.
Okay.
Then we can use asynchronous first.
Ma'am, it is level.
Register
Register is edge triggered and the latch is level triggered.
Okay, some of you told latch doesn't store any data. Is that correct?
No, madam.
It stores, ma'am.
How much? How much data it will
1
be stored?
1 bit.
1 bit data.
Bit
Then
of
what
data.
about register? Then what about register?
Group of flip-flops.
Sequence of data.
Okay. How much data is stored by the register?
Based on how many flip-flops we are using.
Depends on what we are initializing.
Okay. Then what is meant by flip-flop?
For single element, single bit.
Single bit storage element. Okay.
It will store only.
Okay. Latch is also storing a single bit data, right? Which one is mostly preferred, whether latch or flip-flop in real time?
Flip-flop. Flip-flops.
Flip-flop,
Ma'am,
ma'am.
Ma'am,
Latch
because
is
it is
supposed to be
level
there
triggered,
for
and if there is any change
level.
between that level, there will be loss of data. Therefore, flip-flops are used because the changes can be noticed as it is an edge triggered.
Okay.
Flip-flops are resistant to
Ma'am, latch
loss.
is a temporary storage element. No?
Okay. Okay, basically latch is a single bit storage element but it works with respect to the level trigger. Because of level trigger, the output doesn't have the controllability. Whenever the input changes, automatically the output will be changed. There will be lot of output changes will be getting it in a time. So to avoid that, and also we will get the race around conditions in the latches because of no controllability at the output side. The inputs are connected in the feedback, right? So that's why the race around conditions will be getting in the latches. To avoid that, mainly we are moving to the edge trigger. By using the edge trigger, we can avoid the race condition. The output will be controlled with respect to the edge of the clock. So that's why edge trigger is used to avoid the race around condition. That edge trigger circuits we call as a flip-flops, where it stores single bit data. But in real time, we cannot use the single bit storage elements. That's why we are moving to the registers, where we can store n bit data. If you want to store 8 bit data, we will cascade 8 number of flip-flops. If you want to store 16 bit data, we can cascade 16 flip-flops. That's what 16 bit register. Okay, what type of flip-flop is used to store the data?
D flip-flop. D flip-flop.
D flip-flop. D flip-flop is one of the memorized state memory state it have. So D flip-flop is used. Okay, so my question is here, what we can do without any data loss between the transmitter and receiver here?
Shift register.
No, registers are not used.
Now we could use a buffer
We
to
can
slow
use
down
bridge.
the input.
Prescalers.
Okay, you can use the buffer to slow down the input. How much data will be stored by using a buffer? What's the size of
1
the
bit.
1 bit? But in real time, do we use the 1 bit? These all are 32 bit, 128 bit transactions, data and address.
Then we can use an asynchronous FIFO.
Asynchronous FIFO.
Yeah.
Why particularly asynchronous FIFO?
Because the clock speeds are different, right? So based upon the handshake and full and empty conditions, we can read and write. So that no data will move.
Okay, so here we can use a FIFO memory. It's a first in first out memory. Okay, so whatever the trend transactions we are sending from the transmitter, all trend transactions 1, 2, 3, 4, 5, 6, 7, 8, like that, one by one, all the data will be stored temporarily in the FIFO based on the receiver timing, by whatever the time it will consider to complete one task. So it will be getting from the FIFO. So first task, after completing the first one, second one, after completing second one, third one, after completing third one, fourth after fifth, like that, one by one the receiver will be getting the data from the FIFO. So in this case, we never get the data loss. Okay.
Ma'am, you are
Yeah.
saying the data and the address are lengths are high, right? Then what will be the depth? What is the depth of the FIFO?
What is the depth? For FIFO depth, we have lot of calculations. Basically, FIFO depth will be the 2 power n we can consider, but we can calculate FIFO depth in a lot of ways. Basically, it depends on memory locations, based these memory locations.
Okay,
Yeah.
understand. Is there any chance of getting full and full condition?
Yeah, of course. For FIFO, we will have the empty and the full conditions. We always need to check the empty and full condition, because FIFO means first in, first out. It's a sequential write and read operation. Whereas a RAM, ROM, or random access, randomly we can write the data into the memory. But in FIFO, sequentially, one by one, based on the pointer. Pointer is nothing but location. Location is nothing but address. So basically, it will be starting from 0th location, first, 2, 3, 4, 5, 6. Writing the data means like this. Writing some data into the memory location. Reading the data means retrieving the data from the memory location. So whenever the FIFO memory reaches some depth, whatever it's a depth, it's a full condition. Whenever the memory is full, we cannot write the data. whenever the memory is empty means a zeroth location. If the memory is empty location, we cannot read the data. So these
Yes.
two conditions we need to follow always.
Yes, ma'am, I understood. But here, for example, here you take the transmitter as a master and the receiver as a slave condition, and you are writing into the FIFO, and the receiver is at slower data rate, so that it can't read that much speedily. If the FIFO is full, in that scenario, the master need to wait for the FIFO empty condition, right? Certain locations, so that here the master time is wasting, right? When it comes coming to the practical scenario, I listen that it is better to waste the slave time, don't waste the master time.
Okay, but without doing the data loss, this is one of the best option in terms of hardware to use the FIFO. So whenever the one by one the location it is reading from the receiver, the data will be moved, it will be shifted like this. So obviously the master doesn't wait much time. You just wait until the one transaction is completed, like that. In that case, we can also take the much depth FIFO, which is more depth.
Oh, okay, ma'am.
Okay.
Yeah.
Is there any other answers from anyone where we can storage the data temporarily here without any data loss?
Ping pong buffers.
Without buffer?
Ping pong buffer.
Ping pong buffer.
Like there are two buffers.
Okay.
While writing into the first of all, I write the, for example, top and down is there. I'm writing on the top. Writing in the down buffer, I'm writing from the top buffer. Like that, toggling is there.
Okay. But buffer doesn't work with the complex circuits, I think so. Buffer is just like works for a delay to increase the delay of some combinational circuit. But here
Yes.
we are working with the 128-bit, 64-bit means the buffer doesn't work.
Okay, ma'am. Ma'am, here
Here
one more doubt. What is the maximum frequency that AXI and APB both can handle? You said different
in
frequencies.
terms of AXI, mostly in terms of gigahertz only. APB just in megahertz, just 100 megahertz, like that.
Is there any chance to change the frequency, operating frequency based upon the versions?
Yeah.
Like AXI 3, AXI.
Yes. There are a lot of versions. Versions means the mostly features will be dependent. Suppose APB protocol means it's a very basic protocol where we have few few signals like just a clock, reset, address, data, write or read, P ready signal, P slave error, P protector, like very few, less than 10 signal. But if we go to AXI, there will be channels. That means nearly there will be 5 channels. Each channel there will be nearly 50 signals. That means not double, not triple. It is 10 times more than APB protocol. 10 times more than APB. So features also will be more. Whenever the features are more, automatically the speed will be high. So every version, the version is differentiating means the features will be more. Like XA protocol, there are a lot of features like a burst transfers, out of order transactions, overlapping. There are a lot of features, but APB doesn't have those like that. Automatically, the frequency will be improved.
Okay.
Okay. So next, I think one girl asked the doubt. I think now you got the answer. Are you there?
Yes, ma'am.
Okay. Okay, so like that, there are various protocols. We will discuss one by one now. Okay, this is entire system on chip design. To transfer any data from one block to another block, we need to follow certain rules. This is what the different types of protocols we use in real time. Okay, first on-chip bus protocols. Okay, there are some open source and also which are majorly used in the companies. Okay, at your level, at student level, you can learn only open source like APB, AHB, AXI, UART, I2C, SPI, PCI, USB, Ethernet. These are what you can learn. But other than this, there are a lot of protocols. Okay, you will get the clarity today. So, on-chip protocols means the bus protocol where I have shown here the big interconnects. And also if you see here, there is a green color and a blue color. Before I told you, the verification will be different with the core test cases and normal RTL design test cases. Okay. So specially there is a coherent interconnect for N core. That means specially designed for the core test cases. Okay, because the data transmission will be different because it have lot of register banks, the instruction sets, everything is different, which is a coherent. That means specially designed for core. Non-coherent means for RTL design, which doesn't involve any instruction set, any process like that. Okay, so here in the coherent or non-coherent, whatever, there are bus protocols, which is a AMBA. AMBA means APB, AHB, AXI protocol. Okay, so higher side, that means high frequency side, we use AXI protocol. Lower frequency IO peripheral side, we use APB protocol. In between these two, for making the synchronization without any data loss, we use a bridge. That bridge is nothing but specially designed based on the AXI features and APB features. It's like a FSM, not FSM. It's like a FIFO, but FIFO is different structure. This bridge is different. This bridge should get the inputs of AXI, which are based on AXI features. Because the signals are different, right? The signal pronunciations, everything is different, whatever we use. And APB signals will be very less signals. Okay, just like a example, simple example. There is a water tank. There is a water tank. This is what the AXI. This is what the features have. In this water tank, there are full of water in the tank. But I have a bottle, small bottle. Okay, now if I want to put this entire tank to the water bottle, okay, how much water will I get in this bottle? Maybe half water or even full water. Remaining all this tank of water will get wasted, right? Remaining all this tank of water will get wasted. That's what exactly the data transmission here. 1 million instructions getting per second and lot of write and read data, 128-bit data or 68-bit data, 64-bit data we are sending the transaction mean. This bottle is not able to get all those. This IO peripheral, whatever the functional block, it doesn't have that capability. So here we are using a small bridge. Here bridge is nothing but a water tap. The tap means some small amount of water will get into this bottle. After filling this bottle, we can turn off the tap. After one bottle, again next another bottle, again next another bottle, and again next one. Like that, without wasting the water, this tap is working as a bridge. That's what the bridge exactly mean. So here the processor is sending 128-bit data or even 256-bit data at a time. But this functional block, which is a small camera module or small Bluetooth module or Wi-Fi module, is not able to get that 128-bit data at a time. So it will get in terms of bus, in terms of small amount of data, like 32-bit one time, next 32-bit in second transaction, in next 32-bit in in third transaction, next 32-bit in fourth. Like that, small amount of data will be getting to this block. That's what exactly AXI to APB, and this is what the bridge will control the address and the data. Okay, clear?
Yes, ma'am.
And like that, there are different protocols like a Wishbone, Core Connect by IBM, Avalon by Intel. These all are their protocols particularly used for their projects, not open source. Okay, and there are some network on chip protocol like a mesh based Taurus hybrid. We have the network on chip, right? Like a system on chip, there are network on chip. And memory interface protocols, mostly DDR, double data rate here, like how the data is transferred, the speed of data, okay, processor to memory. So DDR, DDR1, DDR2, DDR3, DDR4, DDR5. In this particular course we will be learning DDR also, RISC-V processor. That means processor related one project, memory related one project, remaining all protocols. So you will be learning this project also, DDR, for RTL design and verification. And LPDDR is like a SDRAM. HBM, GDDR, it's a graphics related DDR. These all are not open source. These all are specifically designed in the their own requirement, based on own requirement. And there is a high speed communication protocols, which is a PCIe, USB. In USB there are a lot of versions. You already know what is meant by USB protocol. Every computer, most of the digital gadgets like a printer, scanners, even laptops, there are USB protocols for data transfer. That's port where it transfers the data by following certain rules. PCI is one of the very high speed protocol. Within just fraction of seconds it transfer the data in terms of lanes. Yesterday in the motherboard I have shown you PCIe slots, PCIe lanes. So this is where the processor and memory ports will be get communicated using these PCIe lanes. Okay, so that is what one protocol. But if you are a fresher level, you don't need to concentrate on that. But if you have 3 years or 4 years experience in design verification, you must learn PCIe, because nowadays in market there is a very high demand for PCIe and USB. And there is a SATA protocol, NVM, Thunderbolt, CXL. These all are not. CXL is also PCIe related. PCIe, for PCIe, advanced one is a CXL protocol. Okay. And
Ma'am, I have one doubt, basic doubt.
Yeah, tell.
Yeah, what is the difference between motherboard and SOC?
Motherboard, see, motherboard means here, if you observe this blue color one, it's a PCB board. It's a very bulk size PCB board. On top of PCB board, we have connected lot of ports. Like it's a processor. This big one is a processor. If you're gaming, if you are using gaming related or Photoshop related, there will be a graphic processor on motherboard. Especially we need to put the graphic processor on motherboard. Only if you have the requirement, then we need to buy it separately and we can connect on the motherboard. See, this is how much bulk size GPU. This is what GPUs. It is also same like a processor. If you see here, one side a CPU, one side a GPU. It's like it's also a processor. But if you have a requirement, then only see here graphic cards. These are here left side. These are nothing but graphic cards, GPU. So these all are everything connected individually on the PCB board, the North Bridge IO memory slots, PCIe slots, these memory slots, PCI slots, everything is connected on a individually. But in system on chip design, there is a processor inbuilt with a graphic processor. There is no separate processors and all. It is just a chip. It is just integrated. It will be in size of like this. If you see here, what the integrated circuit here, CPU and GPU. It will be in the same way. On top of that, there will be different integrated circuit functional blocks, not components. Okay. In system on chip design, you never find all these capacitors, resistors, everything. It's a system on, it's a simple chip. That's it. On chip, there will be multiple blocks. But a motherboard is not a chip. It's a PCB board. On the PCB board, we will put lot of components. That's the difference.
Okay, ma'am. Got it.
Hello, ma'am. I have one doubt.
Tell.
Ma'am, PCB boards colors are many colors are there, but it's indicate any information.
Yeah, of course. PCB board means it just some material, just some material, I think so. Whatever the board, we will make the connections with the soldering and all. That is just matter. It will be any color.
Okay,
See here, SOC in the sense this is a chip. On top of chip, we will just put different functional blocks. It is very smart. It doesn't have the resistors, capacitors, everything. Less complex.
Ma'am, can you tell me GPU and CPU main difference?
GPU and CPU is for general purpose instructions. It just perform the arithmetic and logical operations and it do the task, general purpose task, just opening the software, controlling the softwares, and it just connect with the OS. That's it, general purpose. But graphic processor means specially for the high quality pictures, high quality video gaming purpose, or if you are working with a Photoshop, for the complex softwares, if you want to run very fast, we use the graphic processor. Just take a simple example. You just buy, you just no need to buy, you just check with your friends also. Someone have the normal laptop, HP or Dell, like that normal laptop, and someone have the gaming laptops. The difference you can observe there itself. The gaming laptops which will be very bulk size because it have graphic cards inside it. Okay, in that only the Photoshop or we will Adobe, these softwares will be there, right? For video making purpose, those softwares will work with the graphic cards only. Normal central processors, normal general processor, they cannot they doesn't have the capable of running that frequency. Did you understood now?
Yeah, ma'am.
Graphic processors are specially designed with a high level of cores, which can control, which have the capability of running these type of softwares. Just provide the extra quality of videos, extra quality of pictures. That's it. And even if you observe the good quality of mobile phones, why we tell it as it is a good quality? Because it have more cores and also graphic processors. Now everything in olden days we have used a separate graphic processor, separate general purpose processors in the motherboard. But in nowadays, most of the laptops and mobile phones getting integrated graphic cards. That's what the difference between system on chip design, monolithic and multi-chiplet. Monolithic means where doesn't have the integrated graphic card. Multi-chiplet means where it have the integrated graphic cards. So most of the SOCs will be designed in the same way. Even you can check the difference. There will be lot of dice. Multi-chiplet means that it will be there will be lot of dice for cores, core 1, core 2, chiplet. See here. See here. In previous motherboards, do we have like this chiplets? Never. We don't have the chiplets. Only in SOC, that too monolithic means it just have one chiplet. It just have one die. In that die only, there will be a processor, there will be a graphic processor, IO peripherals, everything. But here chiplet means one die will be divided into the different cores, CCX, CCX1, CCX2, like that, and it have separate core die and IOD. That's what the difference in SOC is. There will be a lot of different chiplets. Okay. Don't worry. Once you just get placed into some company, anyway, you will do with these different projects, right? So you will get the best knowledge from that if you are working with the IP level or SOC level. So before, if you are in a student level, you just need to focus on the basic protocols and any 2 or 3 projects in your resume. Okay. So next thing is peripheral interface protocol. So what are the different peripheral interface protocols we have, like I2C, SPI, UART? Okay, again in this there are different, like what are serial communication, what are low speed, high speed, intra communication, intercommunication. If you see these 3 examples, UART, SPI, and I2C. UART is a intra communication. That means outside devices. As I shown you before, our laptop is communicated with the mobile phone by using USB protocol. USB is the now present trend, but oldest version is UART protocol. Like that, I2C and SPI within system, these are used to communicate. Okay, I can tell you the best example for I2C protocol. Suppose can anyone tell what is the difference between microprocessor and microcontroller?
Yeah, ma'am. Whereas microprocessor does not contain any memories. Coming to the microcontroller, it consists of internally memories.
Okay. Applications?
Applications like microprocessor, the best example is laptops, ma'am. And microcontrollers, like by the laptops you can use microcontroller and microprocessor, where mainly microcontroller examples like ACs, washing machines, vacuum cleaners, etc.
Like microcontrollers
A
are mostly used
microprocessor
in
is used for
embedded
general
systems.
purpose computing, whereas microcontroller for embedded.
Okay. Remaining any answers?
Microprocessor is heart of the CPUs, ma'am. And microcontroller is the heart of the embedded system.
Microprocessor need a peripherals, ma'am, outside peripherals, but microcontrollers is include the peripherals and include the all memory device, memory accessing.
Okay. Okay. Microprocessor is nothing but which performs the general task, same as before we talked about the general purpose processor, right? Whereas a microcontroller, it performs specific task, like embedded system applications like washing machine and refrigerator, AC, oven. Suppose if you take the example of washing machine, it just wash the clothes and dry the clothes. That is what the specific assembly program we dump into the microcontroller, so that it will work as a washing machine only. Washing machine never work as a refrigerator. Refrigerator code will be different, like just for a cooling purpose, and like that oven just for heating, it just hot the food. So it never work as a refrigerator, right? Microcontroller, it performs specific task. Okay, example, suppose I'm taking a washing machine. Okay, washing machine means what? It have two microcontrollers inside it. So it's a one microcontroller and it's a second microcontroller. Okay, so to this microcontroller there will be lot of sensors will be connected, right? One sensor will be checking for water level, because once the water is put into the washing machine, it need to check the level of water. Once it reach to maximum level, it should turn off the water. So it should have the water level sensor to check the water, and it should have some LCD display to display the time, and also to display some features. And it should have some motors. If you observe, washing will run the motor at some position, at some angle, like in clockwise direction, and the drying purpose it will run anti-clockwise direction. So it have some motors. And also, if you see, both the microcontrollers will not work at the same time. Okay, once it do the washing, first microcontroller will do the washing operation. After ton of this washing, then second microcontroller will do the dry. Okay, dry or spin, whatever. Okay, so it have different microcontroller, 2 or 3 microcontrollers. Okay, so we are going to design in this specifically in this course the I2C protocol specially used to control in this example, to control the microcontrollers. Okay, I2C protocol is a multi-master single slave, or even multi-slave also we can connect. Multi-master means what? This microcontroller is one master, this microcontroller is second master, and there is a third microcontroller, third master, and there is a fourth microcontroller, fourth master. That means one is for washing purpose, one is for spin purpose, one is for dry purpose, like that. Okay, so now we will connect all these microcontrollers to a I2C protocol bus. There will be a I2C protocol hardware here. So this I2C protocol is a bus. What it will do? Bus in the sense it will transfer the data. Okay. Now in these 4 microcontrollers have a confusion which microcontroller should come first, which microcontroller should do the task first. Okay, in I2C protocol we have a special concept like a arbitration. Okay, by using the arbitration concept we can control any of the microcontroller. The bus is one to the microcontroller 1 example. So first of all, this microcontroller will do its task like washing the clothes. Washing the clothes means first of all it put the water into the washing machine, it check the water level. Once the water level is reached maximum, it will display some timing. At the same time, it just motor will be run according to this microcontroller coding. So once this microcontroller task is completed, that is washing, it will send the reply to the I2C bus, and the arbitration will be done now with these 3. Competition means which one should won the bus first, so that which one will do the task next, like that. So now master 2 will won the bus, so the master 2 will be activated, like microcontroller 2 will be activated. It do some drying or spinning of washing machine, that purpose. And microcontroller will 3 will get the opportunity now to do the task, and it do some dry purpose or whatever. Okay, so this is what exactly the I2C protocol works between 2 different microcontrollers to transfer the data. Even SPI also same. Okay, UART protocol is a outside the chip. I have explained I2C and SPI. Everything clear here, everyone? I'm just explaining the top level application. But if you want to learn very in-depth of hardware level block diagrams, coding, RTL design, system Verilog verification, then you need to join for the course. Is it clear, everyone? Application?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, like that UART protocol. UART is the same as USB protocol. UART means what? Universal Asynchronous Receiver Transmitter. It's a asynchronous protocol. That means there is a transmitter and there is a receiver. Asynchronous means what? There is no clock. How we can transfer the data if there is no clock?
Handshaking. Handshaking.
How can we handshake? Handshaking means?
Like, for example, you are the transmitter.
We can send the data by bandwidth.
We can send the data by bandwidth. Any other answer? Actually, this two doesn't have the clock. Here in UART protocol, we use a baud rate concept. Baud rate concept means it's a external clock where we make the synchronization between transmitter and receiver. We use the start condition and stop condition in UART. Start signal, start bit, stop bit. And we will send the data and we check the parity, even parity, odd parity, and the stop signal will get. This is how the UART, the data will be transmitted, binary. So this is my laptop. There is a port. Nowadays, everything is USB port. We can even transfer 128-bit data to 56-bit data. This is my mobile phone. But the olden days, the first protocol is a UART protocol where we can transfer only 8-bit data. And this is what actual process we do here by using the start condition and stop condition. And by using the baud rate concept, we make the synchronization here and transmit the 8-bit data. If the data is not reaching the output here, we will have the parity checking mechanism. Parity means it doesn't even give the error. It just detects whether the data is sent correctly or not by using the even parity or parity. But next, there is a I2C protocol where we can use the clock. And next there is a AHB-APB, AHB protocol. In that, the error mechanisms will be very good. They don't even check the parity. They will detect the error and also give the clarity what the error, what the data is not getting, where the data is corrupted, and how it should be correct. Everything is given properly in the APB, AHB, AXI. That's what the features they have, the best features. But initially, UART protocol doesn't have all these features. Yeah, please tell.
Ma'am, you are saying here we will check the data is received correct or not by using parity, right? That means it will count the number of ones and number of zeros.
Number of zeros, that's it.
Yeah, I have one doubt. If you are saying at a time 8 bits are transmitted. Yeah, in that both, for example, 4 bits are zeros and 4 bits are ones. And at the receiver end, 1 is toggled as 0 and 0 is toggled as 1. The parity is remains same, but the data is corrupted, right?
Yes. That's what the limitation. That's what the limitation of UART protocol. That in that case, we need to just check manually what the output, because in system Verilog, whenever we write the test plan, we will have the expected value and actual value. So based on that, we can check what exactly we should get the output and what we got. Based on that, we need to understand there is some mistake in the RTL design so that we can change the RTL. But UART protocol doesn't have that feature. That's what I am telling. APB, AHB, AXI have P slave error and P error, or H error, B response, or response. There are a lot of signals where we can detect the error properly. But in UART protocol, we don't have that.
Okay. And you're saying we are using a stop and a start bit, right? Yeah, that means the transmitter will give start and
yes.
I'm not understanding which one.
Whenever start is high, so that the transmitter can initiate the transaction. 8-bit data, it can transfer the 8-bit data. Okay, once it reach the 8-bit data, immediately slave must give the 0, stop bit 0, so that it doesn't accept the data more than 8. It will stop accepting the data till 8-bit only. Again, once transmitter sending as a high stop bit, then slave will get the data. It initiate the data 8-bit. That's what start and stop condition.
Okay, that means you're saying slave will give the acknowledgement like start.
Acknowledgement, yeah. Even in UART protocol, we don't have the word acknowledgement. It doesn't have the feature called acknowledgement. But in I2C protocol, we have the acknowledgement and not acknowledgement signal particularly.
Okay, ma'am.
Can you explain asynchronous without using clock?
Asynchronous means here we use the baud rate. Actually, baud rate is we need to calculate how much bits we are sending per second. Based on that bits per second, we need to calculate the baud rate. So we will maintain that frequency at transmitter side, and manually, everything is manually. Frequency receiver side also, we need to maintain that frequency based on baud rate. Suppose there are some standard baud rates like a 1152 0 bits per second. So like this is what the baud rate, how many bits we need to transfer per second. Okay.
Madam, hello.
Yeah, hello.
Sorry for interruption. If we start, could you please explain how to start a project on AXA protocol, madam? How to start or attempt the protocol project?
First of all, you cannot go directly with the AXI protocol. You need to start with the APB protocol. APB is the basic one. Okay. APB protocol, then AXI, then AHB. First of all, you need to understand the features. There will be some features. Suppose APB protocol means what are the applications you just understand. First of all, suppose here there is a block diagram. Suppose here there is a block diagram. The core side, core is a very high speed, and memory is also high speed, and its external memory is also high speed. For this purpose, we use the AXI interconnect, and the right hand side there is a GPIO, SPI, I2C, timer, RTC. These all are low peripherals, IO peripherals, works at very low speed. This side we use APB protocol. Okay, if you want to go with the self-learn, you need to understand the specification, entire specification easy firstly. Okay, that means what are the signals out there. For APB protocol, we will have the signals like clock, reset, address, data, write, reader, P protector, P slave error, P slave error, P protect, P write, not P write, wait state. Wait state will be this. So first of all, you need to understand these, and there will be some waveforms. Like I can show you. Okay, I think I have deleted here. Like in APB, we have AHB. In AHB, we will have like this. What are the signals? What is the master and what are the slave? And what are the master and slave signals will be there. Here, write data, write address, H select, H order data. And here master in same APB also have these signals, but AHB have lot of signals. Like if you see here, burst, trans, master, locker. You need to understand what exactly these signals do, and there will be waveforms like these concepts will be there. These are little bit confusion concepts, but you can learn ideal, busy, non-sequence. These all are waveforms. APB have very easy waveforms. Just with respect to the write and read operation. What is the wait state and not wait state, like that there are a lot of cases you need to understand. AHB we will have these cases. Okay, so you need to understand the specification properly and you need to design the RTL. Suppose if I show you the codes for AHB and APB, AXI. These are very complex codes, but maybe I think you are one you cannot learn. So this is what I have shown you, right? Here the PDF. What are the, suppose AHB protocol it is. What are the signals out there here? Transfers, ideal, 00, busy state, non-sequencer, sequencer. Like that we will take here non-sequence, sequencer, busy, ideal, OK response, error response for AHB protocol. And we will write the interface, which is UVM here. And coming to the design code, inside how the slave ideal state, operation state, how it is working, the bus transfers, like this we need to write the code for RTL design. In this course we will explain all these every line to line. After writing the design, this is what the UVM for AHB, how to write the UVM code. We will every time for a system Verilog or UVM, you need to start with the interface block first, transaction block first. In system Verilog, we have the generator, how to write the generator, or in UVM we have the sequence and sequencer. In sequence we write the test cases. If you see here, AHB single transaction, like that we will have the burst transactions, multiple order transactions. We write the number of test cases. This is one test case in AHB. Like that increment order, one test case, wrap, one test case. Like that whatever here I have shown you, these are the waveforms. Here if you see master lock is one feature, one test case. Here burst transfers. Here we will have the incrementing burst, wrapping burst. Is it visible, everyone?
Yes,
In
Yes,
wrapping
yes.
burst,
Yes,
in
ma'am.
wrapping burst, there will be 4-bit, 8-bit. In incrementer, there will be 4-bit increment, 8-bit increment. You need to understand these waveforms. According to that, you need to write the design. According to that, you need to verify the UVM code. So like that, we will have the test cases here. This is AHB wrap sequence test case. This is for increment sequence test case, and single transaction test case without any bus transfers, like that. After sequence, we need to write the sequencer in UVM. First of all, you need to have the good understanding of UVM test venture. What is meant by sequence, sequencer, driver, monitor, scoreboard, top level environment test, these things. Do you have idea?
Yes, ma'am.
Okay, so that is what the flow you need to follow. AHB, then AXI. AXI is a somewhat complex, like it have the multiple channels. In channels, there will be a lot of signals. Based on the signals, we basically for AXI, we have the VIP development. VIP development is most important for AXI. We use the QuestaSim tool actually. We will give the QuestaSim tool for you.
Ma'am,
Mm.
hello. Ma'am, what is the difference between interconnect and interface?
Interface, where you have seen the interface.
Like while you're sharing the screen, I am seeing that interconnect, but when I'm talking,
That
already talk as
interface,
interface.
that interconnect is different. Here interface is different. If you know Verilog HDL programming, we interface the design with the test bench. How we interface the design and test bench in Verilog?
Instantiation use.
By
By using
instantiation.
a DUT instantiation. That's what we call interface. In system Verilog, same concept, but it's what somewhat complex interface. In UVM also, it's somewhat complex, we call interface, virtual interface. Interconnect is in a SOC level where all subsystems will be connected in one bus. That's what interconnect. Okay, this is what the AXI protocol VIP development in UVM. This is what entire VIP will be explaining in this course in AXI. Okay, like that you need to follow if you want to go with the self-learning. Self-learning mostly I can't tell it is not possible, but that's up to you. Okay. Any
Okay,
other
okay.
doubts you have?
Ma'am,
There are
these days
more
recruiters are asking like for experience.
Ma'am, when will you share the class recording?
already I have uploaded yesterday session class recording. Today also I will upload in YouTube. You can go in YouTube. And I have not completed these sub classification of SOC protocol. I will. You can find this session link in YouTube also. SOC protocol session is there. In that session you will get. We will upload only demo sessions on YouTube, so you can check there. Okay.
Okay.
Ma'am,
Ma'am,
recruiters
do you
are
have
asking
provided
for
any
experience.
certificates, ma'am, this 2-day section?
Yeah, we have the attendance. We will provide the certification for you.
Okay, ma'am.
Okay. And also
Okay.
please write your review in Google ProV Logic. So we will send the certification after
How to
writing.
write, ma'am?
You just search here ProV Logic. Here you will have reviews. You can write here. Okay. Yeah, please tell. If anyone looking for the offline training, we are providing the best offline training also with mock interviews every week and on tests every Friday here, and also providing 5 major projects and 5 major protocols and projects. And also we are mainly concentrating on communication skills, because as you are a freshers, most of you know the concept how to write the code and all, but you are lagging mostly how to explain the way of explanation. So that's what mainly we are concentrating in offline training. So if anyone interested can even you can refer to your friends also. Okay.
Hi, ma'am. Just a doubt.
Ma'am, can we
Recruiters are
find
asking
these
for experience.
topic related specifications somewhere in Google or somewhere, ma'am?
Yeah, you will get the specifications. You need to check with the versions and you can pick.
Okay, ma'am, just the specification, or can we get the code also? Like
code, you won't get anywhere.
Okay, ma'am. Thank you.
Yeah.
Hi, ma'am. Just doubt.
Ma'am,
Will I get an
I wanted
opportunity
some
to?
insights about
Wait,
architectural.
one girl is talking.
Thank you, ma'am. So, will I get an opportunity to learn register abstraction layer concepts in this training?
Yeah, of course.
Okay.
RAL model.
Yeah. Ma'am,
We are majorly focusing on RAL. Actually, RAL model is one of the most interesting topic for me. I love RAL model.
Yeah, ma'am. So currently I'm doing verification in SpecMan e-language. So
Okay.
will it become difficult for me to switch from SpecMan to System Verilog?
Okay, so you want to switch, but in System Verilog we don't have these RAL concepts.
Okay. So then, then how do we verify registers?
UVM.
Okay. Okay. Yeah. In UVM, there's register abstraction layer concepts, right? Okay.
Yeah.
So my doubt was that will this protocol course will cover that topic too?
RAL model we can cover. Actually, that concept is not included in this, but if you want, we can cover that extra.
Okay. Okay. Thank
you. Remaining, what are the doubts you have?
These days recruiters are asking for experience even with freshers.
Okay. Which year passed out you are?
I just passed out in April, ma'am. MTech.
MTech, then BTech?
BTech I passed out in 24, ma'am.
24. 24 BTech, 25 MTech.
23 BTech, ma'am. 25 MTech.
Okay. 23, even 24 also have lot of placements. You should have proper resume. What the skill set it is asking outside.
I have done almost all the projects what you have explained also, ma'am. I have
Okay,
a
then
good
once
resume.
share your resume to me. Even in last week also, some of our students, 24 BTech passed outs already placed in Bangalore. Yeah.
But they are asking like recruiters are rejecting just by looking at like fresher thing itself on the resume.
Okay. Yeah, it's
Because
happening.
I have done my MTech just passed out from MS Ramaya College, which I guess is a like top college in Karnataka.
Okay.
So, not even a single company visited the campus, ma'am.
Yeah,
Then
VLSI
connected.
companies never come to campus. Only they prefer IITs, NITs, BITS, Pilani. Those type of colleges only. Okay,
So
no
how
problem.
to get
Once
placed?
share me your resume, I will forward with our team. Okay.
How do I reach out, ma'am?
Yesterday I have shared one contact number, right?
I didn't get where it was, ma'am.
Okay. Even you can check here in. This one. 918. This will be.
Okay, ma'am.
Okay. Others, do you have any other doubts?
Yeah, I do have. So I have about like 4 years of experience as SOC design engineer. I worked in a startup company and in Singapore, and I quit my job and then returned to India. Like it's been 6 months. So I'm like now I'm planning to get back into the job market here in India. So I do get an initial call back, but later on I don't get like going to the further interview round. So I'm not sure like how to address this. Every
Can
time
you
I do
share
apply
your
a job
resume?
and
Yeah,
sure, I'll
share me your
share my
resume.
resume. Yeah,
Yeah.
sure.
Others, resume is also important. Resume format. Previously, I have given resume format to different people. I have changed the resume format for 2022 passed outs mostly. They got hired after changing the resume format.
Okay. Because I do get a initial call back. We do have a phone call interview, but later on it does not. They'll say that they'll get back to me, and then I don't hear back from them.
Okay.
So I'm not sure like where the issue lies.
We will take a mock interview for you.
Sure.
We will see how much you are able to answer.
Sure. Okay.
Okay, you can send to that WhatsApp number.
Sure.
Okay, guys. So if you are having any doubts, you can reach out to us. Okay. If you are interested in
Madam,
Hello?
Yet.
Actually, I have one doubt. Now I am working in IC packaging line for the past 1 year. So actually, my background is MTech VLSI design only. So shall I switch over now to again VLSI if possible? If I take your course, can I able to like get
Packaging
some
in,
opportunity in VLSI?
packaging in the sense, is it not related to semiconductor?
It's semiconductor package only, IC packaging.
Okay.
Like
Okay.
die bonding, wire bonding, the final backend.
Okay.
So yes. So
You
now
want
is
to
it
switch to
possible to
design
switch over?
verification?
Yes, again VLSI design.
Currently, in which company you are working?
I'm working in Tata, ma'am.
Okay.
Tata
Okay.
Electronics.
You can switch. You can switch. That's not a problem. You can switch. You can contact to this number once. Okay.
Okay.
We will respond to you, or else you can share me your number.
Okay, ma'am. Sure.
Can you
Okay.
please share the number again, ma'am?
Okay.
Ma'am,
Yeah, please tell.
ma'am, I'm
You
recently
just share me,
graduated.
Bhanu Teja, you just share me your number here in chat box. I will note it down and I can forward to our team. Actually, my WhatsApp number yesterday just banned. That's why I'm not able to share the WhatsApp number which I have.
Well, the problem is I'm not able to type in chat.
We couldn't able to send our contact numbers in the chat, madam.
Okay. Okay, wait. I'm sending then. Okay, I have shared here. You can message to that number. Okay, any other doubts remaining?
I had
Ma'am,
one doubt, ma'am.
Yeah, tell. And also, everyone, thank you for joining.
Can
I
you
guess
send the
I'll go
resume
first.
formats?
Yeah.
Thank you, ma'am, for sharing
Hello?
more content.
Can you hear me?
Ma'am.
Oh,
Yeah. I'm there.
Okay. I had one question on would the recording be shared?
Okay.
Hello?
I need to remove the recording. I need to off the recording.
No, is recording possible to be shared?
Yeah. Already we have uploaded yesterday's session on YouTube. Today's
Okay.
session also we will upload on YouTube. You can check
Awesome.
there.
Okay. And then I had one question about the packages. So the thing is, you said the course is starting today, or?
These projects and protocol courses starting from next almost these 2 sessions are completed with a demo, right? From next week onwards, exactly we will be starting with what are the, again I will start with the what are the different types of protocols or the use of different protocols. Second session UART total specification, features, RTL design verification, and I2C, like that. I will share you the curriculum.
Yeah, that would be great. Yeah. So if I message that number, you can share the curriculum, or?
Yeah. Just a second.
Yeah.
Is the screen visible?
No. Oh, now it's visible. Yes.
This is what the curriculum we have planned for 10 weeks actually. If we can't complete in 10 weeks, we can extend for 1 or 2 weeks also, but we will complete whatever we have given in this. So this is what entire structure: week 1, week 2, week 3, 4, 5, 6 till 10 weeks. Week 1 will be total protocol introduction and all. Mostly I will start next week UART also, because I already completed this week. Like that. This is what total detailed curriculum, what you will be learning in UART, what you will be learning in I2C, APB, AHB, AXI. I have given detailedly RISC processor, DDR memory.
Okay.
Ma'am, I have a doubt.
Yeah, well.
Ma'am, present I'm pursuing my BTech in 4-1.
Okay.
But my institution is not giving a chance to have internships like present days. The academic is going on.
Okay.
So I've decided to have like an internship in ProLogic.
Okay.
In the 4-2. So because I have only the chance to have an internship in 4-2.
Okay.
Yeah, ma'am. So so they have declared that with you can have a chance taking internships in 4-2.
Okay, okay. So you are planning for 6 months internship, huh?
Yeah, ma'am. We're only available in 4-2 because
You
there is
can
no.
take online also, right? You don't need to tell them what you are learning. You can even take online if you are interested.
But I want to take offline, ma'am, because see, learning with the offline is different comparing to the online, no, ma'am. I only prefer offline most of the times.
Okay. Okay. Okay, then 4-2 in 4-2 you can come to offline. But still if you want to learn from now onwards, then you can prefer online. Or
Yeah,
else you
okay.
can come to offline in 4-2.
Yeah, okay.
Okay.
How much is the course?
Which course?
This the one we just went over,
This
the
protocol and
protocols.
projects. These all 5 protocols, 2 projects in SVUVM verification is 20,000 rupees.
Okay. And then what if, like, if we want to access only recordings or something, is that cheaper? Or
Yeah, that will be provided.
so okay, but is like if we want to decide later on, the course has already started, then what is the option?
So what?
So let's say we need some time to decide, but course is already happening. So let's say 10 weeks from now we decide. So then is it still possible?
The
Or
course actually starting from next week. These 2 days are just introduction session just to create the awareness for the students.
okay.
Course is starting from next week. Next week we will be starting with the same course, week 1. Next week is the week 1.
Where can I find this PDF?
Yeah.
No, where can I find this PDF?
You can find in LinkedIn also.
LinkedIn,
Are you
okay.
there in LinkedIn?
Got it. Okay. And then you said there's also a PCIe course?
PCIe also available. You can find here.
Okay. Okay.
Ma'am, can I learn this in 4-2 also?
Yeah, you can learn anytime.
Yeah, okay, ma'am. Thank you, ma'am.
Okay.
Ma'am,
Yeah, tell.
I'm recently graduate, ma'am. I want to start a career in physical design, physical engineer, ma'am. When the new batch will start from?
New batch is starting from October first week after Dasara, from Monday onwards.
Okay, ma'am.
October 5th.
Okay, ma'am.
Is there any special coupon or discount for attending the session?
No special coupons or discount.
Okay.
Ma'am, how to apply for companies like go ahead in the off-campus way?
You can follow up in the LinkedIn HRs. Mostly you can follow up that your technical acquisition managers will be there, and we will get the lot of posts, right? Like openings posts. You can search there.
I do follow many, and I also apply like every day almost.
TrueChip
200.
TrueChip solutions have the openings for freshers.
I have almost applied like 5-6 times, so only for TrueChip, I guess, ma'am. No
Oh,
reply comes
last week,
just by seeing that.
our students, 3 members got 24 passed outs.
Okay, okay, okay.
I had one question, ma'am, for UART. You were mentioning some UART. There is you're almost finished with the project?
Nothing is finished.
Okay, okay. So how are
Just
you approaching UART? Is it just receiver transmitter, or are you also doing like baud rate controller, DMA? Like how are you doing?
total UART protocol, how the transmitter and receiver. I can show you a sample.
Okay.
UART protocol, basically most of the people will do with this is frame format. Frame format is a very simple thing. Is the screen visible?
Yeah, it's visible.
Frame format is very simple. Even you can do with FSM also. You need to take the states, start bit state, data bit state, parity state, stop bit state. You can write, but here we are taking the this transmitter, this whole block diagram implementation where we have the baud rate generator, UART, transmitter, receiver. So transmitter have this particular block diagram. We will explain everything here. All each block and each signal, how the FSM of a transmitter and how the receiver for receiver block diagram, how the detect start, we need to write the Verilog program, CPO, how to write the program, parity checker, stop bit checker, FSM, and how this will be interconnected, how the data will be transferred. If you see the UART protocol majorly focusing on the RTL design because it have the very complex RTL design. Remaining all focusing on SVUVM mainly.
Got it. So SVU, okay. So then for the UART, are you also using FIFO or no?
No. If you see here, this is what entire RTL design. First of all, what are the three major blocks you have seen here?
The three major, I see the transmitter, I see
Baud
the
rate generator,
baud rate generator, yeah.
UART transmitter. In UART
Yes.
transmitter, there are 4 different blocks, and UART receiver, there are 5 different blocks. Every block we will design here. Baud rate generator is one block here. Like
Okay.
that, UART transmitter have multiplexer, parity, parallel, serial out, FSM. So entire this whatever you have seen here in this block diagram, FSM, piezo, parity generator, and this multiplexer we will be writing here. And this entire multiplexer individually, parity individually, piezo individually, FSM individually. Like that we will write. Like UART receiver, detect start, CPO, parity checker, stop bit checker, RX FSM. Like this, however we have the design here. So for this we are writing the test bench. In UART we have Verilog test bench and UVM test bench also we have. So if you want to learn more in depth of UVM, we will share that also. So like that we will
Awesome.
explain.
And then
Yeah.
the other question was regarding like the RISC-V project you had mentioned. So for that one, what kind of RISC-V project is it?
It's a RISC-V. We have 16-bit pipeline, 5-stage pipeline, 32-bit non-pipeline also we have.
Okay, like
Both.
the 32 SI.
Yeah.
Okay, but that's without the 5-stage.
Yes.
Okay.
With
Okay. And then,
pipeline 5 stages, we have 16-bit.
so what is like the context of that? Like a RISC-V project? Like what is the use case? Since most projects they should show some like a value if someone asks, right?
It's main processor. It's main processor. Before I have shown system on chip design architecture, it have a processor. So the processor have different types like a MIPS based processor, RISC-V processor, CISC processor. So RISC is one of that. In major, if you apply for the jobs for product based companies like ARM, mostly ARM, AMD, they must have the RISC processor in the job description. Any job description, computer verification or CPU verification or ASIC design verification, everywhere they will mention RISC as an additional, yeah.
Okay, and then what was the other project? It was RISC was one project, and the other project was
DDR memory.
DDR memory. So that's like
DDR
SDRAM,
memory.
or is which one?
Not SDRAM. It's we are covering up to DDR5.
DDR5. So so
One
that's like
memory
DRAM.
related, yeah, one memory related, one processor related, remaining all are protocols. However, I have shown here this is SOC.
Yeah.
In this SOC, we have planned. See, if you see here, DDR memory scheduler, this subsystem. Is it visible? Down.
Yeah,
top,
yeah. Oh, down there. Yeah.
down left. So in this memory, we are covering DDR. On top of this CPU, we are covering RISC processor, and remaining all are protocols. This is what we have planned. And these all are most demand in the market.
So then at the end, is there going to be some way to connect all of these projects into an SOC?
Yeah, that's what actually we are doing in offline. We are doing the DMA controller. If the DMA controller is working successful, we can interconnect like this. We already have RISC processor, all these protocols, even DDR, everything we have. We are designing the DMA controller, direct memory access. It's a memory controller. Once it is getting ready, we can connect all like this top level.
That's a separate class or in same class?
Yeah, that's in same cost.
So for the same class, we're doing DMA along with all of these peripherals and
yeah, we are doing that. If it is completed successfully, we can share that also.
Okay. So and then so each time it's a batch, there's no like way we can join asynchronously online or something, or no?
Yes. I just given the contact number here, right? You just put the WhatsApp message to that.
Okay.
So our team will respond.
Absolutely. Thank you.
Yeah. You are from?
I'm Bangalore.
You are from Bangalore.
Yeah.
But your slang is different. Like
I studied abroad.
Okay.
Yeah, thank you.
Okay then.
I have a small doubt. So are we doing the linting and then the static timing analysis as well for the verification, or is it only going to be just the UVM verification and the RTL designing for these projects?
Do you want static timing analysis?
Yeah, it would be really helpful. Like basically we can like further like do any
In this course,
optimization regarding the courses.
Yeah. In this course, we have static timing analysis also in ASIC design verification course, not this protocol and project.
Okay. Only in the ASIC design verification, is it?
Yeah.
Not in this protocol.
No.
Okay.
Yes.
Okay. Got it. Are we doing like functional coverage as well? Like,
Yes,
are we
that is
covering the coverage?
That is the main thing: functional coverage and assertion based verification.
Okay, so for the PCIe protocol, is there any separate course for this, or
PCIe we have separate.
Okay. Can I find that in the web page?
Yeah. Not in web page. You can find in LinkedIn.
Okay. Got it. Yeah. Thank you.
Yeah. Okay. Thank you. Okay, then I think everyone fine. Yeah, please do.
Can you send the resume formats?
Okay, you can just give me a WhatsApp message, or you can message me in LinkedIn. LinkedIn means I can connect with you directly. You can message me in LinkedIn so that I can recognize you.
Okay, ma'am.
Could you show the resume formats?
Yeah, where
once
is giving
here?
feedback?
What?
Could you show the resume format just one time on screen, just so we have an idea?
This is not much preferable. Yeah, this will be good. And also, every time you can take the screenshot this, I can open another one. Actually, I have deleted all the resumes. Okay, I can send you in the LinkedIn. You just message me.
What is your name again, ma'am?
What?
Your name?
My name?
Yeah.
Prasanthi Chanda.
Okay.
Okay. Okay, then thank you all. Bye.